Welcome back, ladies and gentlemen. It's time for 6.3 Similar Polygons. On the screen, you will see the exit question that you'll be asked in today's exit quiz. Take a look at it. It'll come back at you shortly. Today is all about similar polygons, and on your note guide, you will find a place for a definition of similar polygons, and it's a rather stringent definition. Similar polygons are polygons whose corresponding angles are congruent and whose corresponding side lengths are all proportional. That means in order for two polygons to be similar, every single pair of corresponding sides must have the same proportion as the next pair. So if you have a five-sided shape, you're going to have to check all five pairs of corresponding sides. And if you have a 10-sided shape, you're going to have to check all 10 sides of corresponding pairs. Now, you may want to draw a picture and perhaps write down that giant proportion equation down there at the bottom. Altogether, that giant proportion equation has four pairs of corresponding sides, each taken as a ratio of each other. Now, it's necessary for all of these ratios to be equal to each other, so you do, for a quadrilateral in this case, have to check all four. Together, they're all called a statement of proportionality. Now, if you take one at a time, or any one of those four, you get a scale factor, just like what we talked about in 6.2, dealing with maps and other representations of physical objects that are not the same size. You'll also notice a new symbol, and that is the tilde symbol. And the tilde symbol in mathematics is going to represent the word similar. And you'll see on this drawing here, we again have a shape, a quadrilateral ABCD that is similar to EFGH. And just like the congruency symbol, the order in which you put the letters does matter. So the similarity statement itself can tell you a lot about which points correspond to which points. In this case, point A corresponds to point E, and point B corresponds to point F, and on down the line until you're done. Now this presents a little bit of an issue for you because now you're getting a little overwhelmed with symbols. You have four pretty similar looking symbols that all mean different things and have different uses. So the new one today is similar. It's a tilde. We've done congruence, which is an equal sign with a tilde on top. You've dealt with an equal sign, which you've probably learned a little bit more about it this year, ever since forever, but you should know more about it now. And then one that we haven't talked a lot about, but is definitely in the same category, is the double tilde, or the approximately equal symbol. What you need to know above and beyond all else is when to use which. And we talked a little bit about the difference between the congruent symbol and the equal symbol. And there's a very similar argument to be made with the similar symbol. So the similar symbol, just like the congruency symbol, is only used to compare shapes, not lengths or numbers. So if you're using the similarity symbol, you use it to compare a shape, not a number. Whereas on the other hand, if you have an equal sign or an approximately equal sign, those two things are used only to compare numbers or measurements. Well, here's our super secret code for the day. And our one and only example is right next. Now, this is a two-part problem. One part is to find the scale factor that relates these two shapes, and the second part is to find all the missing information. If you think you can do those two things without having me say anything to you, find the scale factor and find all the missing lengths, go right on ahead and try it. Why don't you pause the video and give that a shot? If not, I'll start talking here. So the only given information that we have here is that this quadrilateral WXYZ is similar to MNOP. Now you see that they rotated things to try to confuse you and all that, but we have to come up with a scale factor for these two polygons. So remember, a scale factor relates one pair, we only need one pair of corresponding lengths. And if you look at these drawings, there is actually only one pair of corresponding lengths that we know everything about. Why don't you pause the video and see if you can identify which corresponding lengths are the only ones given. So if we're looking for any two corresponding lengths, the only ones that are there that are totally given to us are x, y, and NO. And if we just simply write them out as a fraction, we will get our scale factor. So 8 over 10 and 4, which simplifies to 4 over 5. Now it's important to remember that we've now written this with everything to do with WXYZ on top and MNOP on the bottom, which means we're going small to big. Small on top, large on the bottom. The second bit is to find all the missing information. So if you haven't tried that yourself, I think now that you have the scale factor, you should be able to do that without any assistance. Pause the video and try that if you haven't already. Okay, so to find the missing information, A, B, and C, one of those things is a lot easier than the other two. You can see from the similarity statement that point Y corresponds to point O, and right here we have angle Y and angle O, and angle O is known and angle Y is not. So finding C is very easy, it's just 135 degrees. The others, however, A and B that is, you will have to set up a set of proportion equations. And to do that, you're going to use your scale factor as one side of your proportion equation. Now our scale factor is written 4 over 5, which takes the small quadrilateral over the big quadrilateral, or anything having to do with WXYZ on top and anything to do with MNOP going on the bottom. So when we write our proportion equations, we know right away that B is going to appear on the top of the other fraction, and A, because it belongs to the larger shape, will go along on the bottom of the shape. So there's really only another couple things to do, and that is just to fill in the 4 blanks. 2 of the 4 will be filled out with your scale factor, and you know that the appropriate variable will go on the bottom or top as to whether it relates to the small quadrilateral or the large quadrilateral. So these are the proportion equations that you get. From there, it's a very simple process of cross product and solve. And you get A is 15 and B is 8. Up at the top of the screen, you will see your homework assignment, and that's all I have for you today.